delete some files, but what is the Pythagorean theorem is what we are talking about. Charlie? Or, sorry, so that's what I wanted to check on, and that's why I said Charlie. In Infinite Campus, you're still coded as Charlie. Do you want me to remove that? Okay, I will remove, I'm going to make a note on my card right now, because I have a card for you. Somebody put it in there, or they mixed you up with somebody else. I will see if I can change it in Infinite Campus. Now, what is a squared plus b squared equals, like, what the heck does that mean?
So pretty much it's a, like whatever the a number is, times a.
What do you mean the a number? What do you mean a? Like just any, a number? Just grab a number?
One side of a triangle, squared.
What do you mean by one side? Side seems really like, I've got some sides of me, like, you know, the jealous side of me, the hungry side of me. We don't like the word side.
What is it called then?
We need to get away from using the word side. So, do you remember what I said? Ooh, not worse. Sorry. Well, actually, line might be better than side, because side could be flat or side could be a line. So, guys, a side, this is the front side of my cell phone, right? A side could be 2D, could be 3D, could be 1D. A side is not a specific word. This remote has a side. It's a two-dimensional object, right? The remote is a three-dimensional object, but the side is a two-dimensional object. What you guys are talking about are edges, but what we want to call them is legs. So to be able to solve any of these Pythagorean theorem problems, what we want to remember is our Pythagorean theorem is leg, we call it A, squared, plus leg, we call it B, squared, equals, what's that third side called? Hypotenuse. Anyone remember why we use hypo?
No, I think they said it was hypotenuse, but I wasn't.
So what you guys have memorized is, oh yeah, it's a squared plus b squared equals c squared, which is true. We use hypotenuse because hypo means below. The hypotenuse is the side below the right angle. Sorry, I realized after I printed these notes that I didn't really leave you much space to like write down the thing we're going to use today. But we're going to write it in every single problem here. The trick with isosceles triangle. Brittany? You should move up. At least one desk. You can move up to right here if you want. Yeah, that's still 6 feet for me. And I just had a COVID test last week, so we know I'm negative. This isosceles triangle is obviously not a right triangle. But when we're given the altitude, actually that might be a word worth highlighting. When we're given the altitude, we now know that since the altitude is the vertical height, to be a vertical height, it must utilize a 90-degree right angle. So to be an altitude, it tells us it's at a 90-degree angle. Right? By being at altitude, it tells us that we're at a 90-degree angle. So we now analyze, well, do I have legs or hypotenuses, or what do I have? Well, when I look at, okay, below, this is why the hypotenuse is called the hypotenuse. I just want you to see it once and then it doesn't really matter. It's beneath the right angle. Geometry has no up, down, left, or right until we give it up, down, left, or right. Right? So I can rotate or manipulate any of my shapes. Hypotenuse, always going to be the longest side, always the side opposite the 90 degree, but what it means is it's below. Hypo means below, right? So, to solve this here, we just look at one of the right triangles. So we're going to say, I know my C. This is either A or B, we don't care. It can be either of them. Now wait. I'm going to cheat a little bit and use a post-it note, but if you guys have a sheet of paper or if you just want to jot this wherever. If A squared plus B squared equals C squared, but I'm not trying to figure out C squared. I'm trying to figure out one of my legs. Ooh, Logan way in the back. Ooh, if I want to make this just a little bit easy to see, if I subtract B squared from both sides, I could say that A squared is C squared minus B squared. And if I want to go a step further, how do I get rid of a square? Not divide by 2. That's the trap door. Square root. So we square root, and to find a leg, guys, you can rewrite this formula. To find a leg, it is the square root of the hypotenuse squared minus the other leg squared. Order of operations is extremely critical here. If I don't square before I subtract, I get it wrong. If I don't subtract before I square root, I get it wrong. So the only way this works is if I very carefully apply that algebra. So I'm gonna solve this problem in two different ways. First, I'm going to use the formula we just derived, but then I'm going to solve it the old kind of clunky way, but that'll always work. So if I use this fun new formula, I'm going to write that out. Well, wait. I can't just write x equals. What would this length right here be? Half of x. So the leg that we're looking for, half of x, will be the square root of 13 squared minus 12 squared. This is not 13 minus 12 and then square it. That would be the wrong order of operations. This is 169 minus 144. We have to do the subtraction before we do the square root. So what is, well, essentially 69 minus 44, because the hundreds are going to cancel each other out. So 25, I think. What's the square root of 25? 5 or negative 5, but we know in this situation the negative doesn't make any sense. So ignore that. Like we talked how mathematically versus what makes sense, right? Mathematically, square root of 25 has 2 answers. Not 3, 2. We only care about one of them, the positive. And if half of x is 5, what's x? 10. Ooh, careful, 10. We got to double it. Remember, we found that this leg is 5, meaning this leg is 5, meaning x is actually 10. Yes?
Where x equals 10, that actually did mess me up on a few problems, because I'm like, oh, it equals, like this part equals 5, so it's like 5, and it's like wrong.
Yep, I know what you mean. Now, the other way that we can do this that always works. Just start with your normal formula. So I'm going to cover this up for a minute. Actually, I'll just work to the side here for a second. Forget about this complicated formula. If I just had my original Pythagorean theorem or Pythagorean formula, I plug in what I know, right? Let's say I don't know a squared, quote unquote. I know my leg, and I know my hypotenuse. Comes out to be the same. There is zero difference because algebra, guys. We've talked about how algebra gives us a ton of options for what we are allowed to do. Just starting from the original Pythagorean and just plugging in and then doing the algebra later, totally fine. Totally fine. But if you want a rule, I know some of you guys really like having rules that we can come back to. The rule that we can say is the missing leg of a triangle. We can use this formula. We can. We don't have to, but we can. Right? Which also means we could derive a slightly simpler formula for the hypotenuse. If I want to derive a formula for just C, how do I get C by itself? I square root, right? So C would equal the square root of A squared plus B squared. Right? We can keep messing with these. We can do anything we want. And that's why for the rest of this class, I don't really care how you solve. You use whatever formula you want to use, but you need to check if you get the same answers as me. And if your mental math isn't super strong, I would grab a calculator if you don't have one at your desk already. Try on your own, probably for less than 5 minutes, but try these other two problems on your own. The other two isosceles. I'm going to keep mine up here. You can use whatever technique you want. You can use the original. Oh, by the way, now is when I'm going to really fall back on card. Those are clean. Yeah, this is when I'm really heavily going to fall back on cards. So my next two voluntolds to help me out here are going to be Audrey and Sarah for our next two isosceles problems. Audrey and Sarah. I just clear it out. It means somebody tried to do math that can't happen.
Okay, so what do you have?
Hit clear.
Oh.
Like that, yeah.
Okay.
Guys, I would always use a calculator. I shouldn't say how I just said that if your mental math skills aren't super strong. What I should say is unless you're trying to challenge yourself by doing it all in your head,